This area is a bit of a conservation area, so they tried a number of different techniques to be more eco-friendly in their parking lot because they have a lot of visitors coming here. And so here's an example of how they're using recycled tires and they're making these bricks out of them. So not only are they creating a permeable surface, so the water can move down through there and into the groundwater, and under there you have a gravel base, so you're storing some of that water and giving it enough time to infiltrate down into the groundwater. But you're also using recycled materials, so you're using two different aspects that are both green. Obviously you have to consider what chemicals are being leached off of these, and I'm sure they took a look at that before they started the project. Over here you can see another type of paver. This is a bit of an experimental area, so they've tried a number of different types to see how it would work. And here's two other different types. So here's your typical cement ones, but then they've got areas for infiltration in between, so allowing it's got a coarser gravel, and that allows for more infiltration of the water into the soil. And you can see it's actually got some moss growing here, so you got some vegetation growing. This one is another, it's more rocks, but you can see that it's got bigger spaces between it, so it actually allows for some sort of infiltration to happen here. It's not so tightly packed together like typical asphalt where nothing can get through. So there's actually an infiltration, and because it's glued together a little bit, it's not moving around. If you just put gravel down here, that would work as well, just holding the soil and allowing for a parking lot to occur here, but also minimizing the amount of erosion and increasing the amount of water infiltration versus a typical concrete pad or an asphalt pad that has no percolation into the groundwater. So behind me is a stormwater pond, and it's basically draining all the water off the land for this large park area that's all grassed, and it's draining into this pond. And what that does is it gives the pond time to settle, and it also has aquatic vegetation and plants around it, so that it's absorbing a lot of the nutrients before it enters into a stream system. And you can see on the edge they've done a good job of planting different tree species, and then it gradually, they've got a good slope on it, so you've got a fringe of aquatic vegetation. And then in the open water, it's deeper, but not so deep that you can't have the submergence and the emergent species all there. So you have vegetation over a good part of the pond, and it's only a small area that's open. You want that open area so that things like ducks and different birds can use that water source, and also you want it deep enough so that with water fluctuations you can have the survival of things like turtles and frogs, because when it freezes over solid, they need that mud deep in the water so it never actually freezes down there, and they can overwinter and survive. So you need these different refugia for overwinter survival. So this is a pretty typical stormwater management pond. Here you can see the inlet structure where it's collecting all the water from the road and from this residential development area. And so the water is coming in here, and then it's going through this baffle so that any sort of material that's plastic or whatever will be caught. A lot of times they put like some sort of a cage here so that the plastic material and whatever is coming down, the garbage, is collected before it enters into the pond system. And down here you can see the water is a little bit murky, a little bit green, so obviously there's some nutrients going into the water, some sediment, and what's happening is it's being held in this place. When the water slows down from coming out of that pipe at a fast speed and off of the roadsides at a fast speed, it hits this pond and it slows down the water, and that drops out the sediments the geese in the background. And it also, once aquatic vegetation establishes, then the nutrients that are in the water will also help to be treated. Toxic chemicals will also be helped to be treated. But this is a new pond, and so you get a bit of an idea of how this works. You've got a sloping side, and that increases the amount of volume, so that as the pond raises, you've got more and more volume, and the slope allows for different species to occur, but there's no vegetation on here right now, no trees, no shrubs. So if they're just leaving it like this, then it's not really a very good example of how to do a stormwater management pond. The other pond that I'll show you is a much better example. And the geese really like it when you just have lawn all around the edge of the pond and there's no shrubs, because the shrubs actually they're afraid of, because they can hide predators. So if you had put shrubs all around this pond, you wouldn't get this geese problem. Other things you can do when you're doing a restoration project and you're going in and you're planting these plants in the water is put up things like fishing line. You put a post in the ground, and then you run fishing line across the pond, and when the geese try to land, they hit the fishing line and it scares them because they can't see it, and so they fly off. Another thing is using what's called bird scare flash tape. It has a red and a silver side, and it's made of a strong material, so that when it is on the side of the pond, you put it posts in the ground, and then you tie the bird scare flash tape to it, and then you run it around with a twist in it, and as it's fluttering the wind, it's going back and forth and flashing, and it stimulates a fire, and so the birds don't go near that. And so you're protecting the aquatic ecosystem, especially when you first plant the pond. The ducks and geese can go around behind you and just go pluck, 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 and eat all your plants. So you need a period where you're protecting the plants. Another option is actually fencing completely the edge of the pond with something like snow fence, and that prevents them having that transition back up to the land, and so they don't like it as much because they have to fly over this barrier all the time to get the grass and fly over it to get to the water. You can also do things like exclusion fences, which is basically, again, using some sort of a snow fence or a fencing and blocking off areas, especially in more residential areas and areas where there's large populations of geese in the area. You need to take those things into consideration, because this predation, when you're putting your nice plants in and you're trying to create an ecosystem, you have to protect the plants from being predated by the herbivores. So just putting a fence around certain areas. If you have a lot of pressure, a place like Coos Paradise in Hamilton actually put a barrier down into the water because they had a major problem with carp, and so you put this barrier, allow the vegetation to reestablish within that protected area, and then you remove the barrier once it's fully established and move on to a new area to reestablish. So some of these urban areas have so many invasive species that you're working with, and so many different pests that you need to consider this when you're doing your ecological restoration project. And here you can see mostly weedy material along the side, and they put in some sort of a turf grass. But really, if you're doing a good ecological restoration, this is all wildflowers, and you've got zones of trees, and you've got zones of shrubs near the water, and then in this zone, about a half-meter elevation, you can put in your wet meadow species. Once you hit the water's edge, down to about a meter, you can put in your emergent species in different zones, and then past a meter, you're putting in your deeper species, your water lilies, your submergent species, down to about 2 or 3 meters, depending on the clarity of the water. And over here, you can see how they've tried to create a little bit of habitat heterogeneity. It's a pretty square pond with not a lot of undulations, but they put a little bit of a point out there. And if you're trying to create more diversity in habitat, you're trying to, more undulations in the pond will create more microhabitats. Here they're like, okay, we don't want to waste our money on creating a nice pond. We're just using the maximum amount of space to store the maximum amount of water without any consideration for wildlife here. And so you could do things like creating islands out in the middle. You could create more points. So just having these different bays and points adds more heterogeneity to the habitat and allows for other species to come in, and more variation in the aquatic species as well, having these shallower and deeper areas. Over here, you can see the water control structure that goes out. So when you're designing a wetland project, you need to understand what the water level is going to be in that pond. Because if you don't understand the hydrology and how the water is moving up and down, then you don't have a good understanding where you should be planting. A lot of times you'll get a blueprint and the designer will say, this is where the water level is that I expect it to be. But then you go and you check the outlet structure and you look and see where exactly the water level is fluctuating to. Here on this pond, it's high right now, but there's a line around the edge of the pond where the water is interacting with the shoreline, and that shows you where the typical water line is going to be and what sort of water level fluctuations are going to happen. So you really need to look at a new project and look how the water level is going to fluctuate, and so that'll determine your zones for planting. This water control structure is basically the outlet. So it comes in on one side and then it comes out on the other. And so depending on how noisy in the background, depending on how the water control structure is, determines how high this water is going to be, how fast the water is removed from this pond, so the residence time, and then it goes out and it'll go into some sort of a stream, or it'll go into a storm drain and then dumped into a creek somewhere down the line. Yeah. You're like, what are you doing? In terms of water control structures, there's two different types that you typically have. There's what's called a top draw and there's a bottom draw. So a top draw is basically some sort of a weir system where the water the top water comes off of the pond, and that, when you're putting it into a pond like this that's shallow, the water heats up considerably because it's being exposed to the sun, and without any sort of vegetation on it, it's warming the water, and then you're putting warm water into a cool water creek, which is, most smaller creeks are usually a cool water stream, and so that's negatively affecting the stream by increasing the temperature. The alternative is bottom draw, which is basically you've got a pipe underneath the water, deeper down, and then in this structure you've got different gates, and so the water's coming from below and then above these gates and then falling over into your pond, or into your, however you're removing from the pond. But the water that you're taking from a bottom draw is from the cooler part of the pond. In the pond you have stratification, so the warm water sits above the cool water, which is heavier, and so you have this what's called stratification, and it creates a layer of warm water and a layer of cooler water below it. And so you want that cooler water to be what's going into your stream. If you have a cool water stream, you don't want warm water changing the chemistry and changing the temperature, having these major flushes of heat is not good for the aquatic ecosystems. Things like trout, which are cooler water species, you start putting warm water in there and they're not going to be very happy. So here's another pond, and it's an example of stormwater management. And here you can see that the water has had a rain recently, and so the water is not very clear. And the water level fluctuation, you can see from this line on the ground here that the water has been coming up to about this line here. So this vegetation is kind of muddy looking, and your tall grass species, your grassland species, are not coming down into this zone because it's much moister. And they've done a good job of establishing this grassland area. You know, later on it'll have much more wildflowers in it. This is a little bit early in the establishment, and along the edge you can see there's some trees. Sorry. Along the edge you can see there's some different tree species, and they've also planted some larger caliper trees in different areas, and a bit of things like sumac, so your pioneer species that'll help pollinize the area. The challenge with planting some of these larger species, everybody always wants this instant forest, and so they're planting large trees and they're doing what's called balled and burlap. So they're cutting the root system off and putting it in a bag and then putting that into the ground. And what happens when you cut off these roots, and a lot of these roots are quite large, and typically for most trees the root system is equal to the height of the tree, is the amount of spread that's going on. So when they're doing this ball and burlap, they're cutting off all the roots that are extending out and then bringing it into a construction site. It can live, but usually it takes 5 years for the root system to re-establish itself out, and before that tree will start to grow again. So basically, if you're bonsaiing the tree, you're cutting off all the roots, and then it stays in a stasis phase. It's alive, but it's much more vulnerable to things like erosion and to periods of drought. I mean, that's one of the reasons they're putting this bag around it for watering, because it needs that water through the dry times, because you've reduced the amount of roots, and what roots, of course, are getting your nutrients in your water, and if it doesn't have that, then it's much more vulnerable. So planting these larger trees is not that great of an idea. Personally, I prefer to plant much smaller trees so that you're limiting the amount of root that you're damaging. And when I'm doing a restoration project, a lot of times you find that planting a 1 liter or 2 liter tree that has good root establishment, maybe it's only a meter and a half tall, but they'll catch up to these ball and burlap trees because they have the root system still intact. And so when they go into the ground in the spring, usually plant them when the spring and when they're dormant, or later in the fall while they're dormant, so you're not damaging the tree as much, and so that they can rapidly reestablish because they've got most of the root system still. So when you plant these smaller trees, I find that even though it's 1.5 meters tall and this one's 3 to 4 meters tall, the smaller tree, because it has an intact root system, catches up to the larger tree within the 5 year time period that this tree needs to reestablish its root system. The other tree grows so fast that it catches up. So there's not much point. Everybody likes the instant tree, but there's not much point in planting them if you don't give it a good root system. And these trees are more susceptible to having root problems in the future because of the damage that's happened to the roots. So this is another example of rainwater management. We looked at some different stormwater ponds, and so this is what's considered a sedge meadow. So we're not keeping water on the surface anymore. We're actually allowing the infiltration, and so this area is keeping fairly moist, but it's not cooling the water like the other area did. So the water is coming in on one side, spreading out into the sedge meadow, and so it allows for the nutrients to be absorbed in the vegetative matter. The water is being absorbed into the soil, so you have more groundwater infiltration. You're also getting groundwater infiltration in the stormwater pond, but in a meadow like this, it's kind of mimicking what the beaver is doing, basically. So in a beaver pond, so we can consider the stormwater ponds to be like the beaver pond initially. They're damming it up, they're impounding the water, holding the water back, and so that's what they're mimicking there. And this is mimicking a beaver pond at a later stage when it's filled in and become a sedge meadow. And usually you need a richer organic layer, more topsoil here, and you also need better infiltration. And so you're getting a whole variety of different grassy species. You've got things like typha and asters, and different sedges and different grasses. So you have a whole different community here that you wouldn't have in the pond. And because it's flowing across the land and infiltrating into the groundwater, it's also recharging the groundwater system at the same time, and the moisture is spreading out into the soil. So it's just a different way of managing your rainwater. And you can see that it's fairly well naturalized here. It's not like a super ecosystem, because there's still a lot of weedy species here, a lot of invasive species. It's inside a city, and so we have all these challenges, especially in city ecosystems with so many different invasive species. But it is functioning. You know, there's birds out here, there's insects out here. They're using this, and there's probably bowls and different things that you can't see in the ground. And it's creating a nice rich soil, because all the stormwater that comes off of the land is dropping all its sediments here, and hopefully by the time it reaches the stream at the exit point, that most of that sediment has been taken out, and most of the nutrients has been taken out before it goes back into a stream system.